Now Huckels' rule of aromaticity. Earlier, benzene and its derivatives having large resonance energies are called as aromatic compounds and their extra stability. But it is later found that the extra stability of the compound observed due to the resonance is not the whole sole criteria to measure the aromaticity of the compound. The aromatic compounds apparently contains alternate double and single bond in a cyclic structure and resembles with benzene. This characteristic behavior is called as the aromatic behavior. Aromaticity is the property of sp2 hybridized planar ring. This means that all the aromatic compounds they will contain the sp2 hybridized carbon atoms or the other atoms, and they will allow the cyclic delocalization of the pi electrons. Now the criteria which are to be satisfied by the aromatic compound. Now first one is an aromatic compound must be a cyclic and planar. If the aromatic compound is not a cyclic and the planar, then there will be no delocalization of the pi electrons. Each atom in an aromatic ring possesses the p orbital, and these p orbitals must be parallel to each other so that the continuous overlapping is possible around the ring. Now suppose if these p orbitals they are not parallel to each other, then what will happen? If one of the p orbital is not parallel and it is perpendicular, or it is at the right angle to the remaining p orbitals, then there will be no proper delocalization of the pi electrons. So all the p orbitals they must be in a parallel position. The cyclic pi molecular orbital formed by overlap of p orbitals must contain 4n plus 2 pi number of electrons. Means total number of pi electrons present in that compound must be equal to 4n plus 2. Now for a single pi bond we know that one pi bond is equal to the 2 electrons. If we consider the structure of the benzene where 3 pi bonds are there, therefore 3s are 2, that is your 6 pi electrons they are present in the benzene ring. Now what is the value of n? If n is equal to 0, 1, 2, 3, that is your whole number, whole complete integer number, then the compound will be aromatic. This is known as the Huckels rule of aromaticity. If the value of n is half integer, that is 1.5, 2.5, 3.5 or anything else which is not a complete integer, then compound is not a aromatic compound. The value of n should be always 1, 2, 3, that is your complete integer. 0 can also be there. If the compound satisfies all these three criteria, then and then only the compound will be called the aromatic compound. Now what is the heterocyclic compound? We'll take the examples of the heterocyclic compounds, whether the compound is aromatic or non-aromatic, or it is not aromatic compound. So we must know what is the heterocyclic compound. An organic compound that contains one or more atoms other than carbon in its ring. That means that it is a cyclic structure. First thing. Second is it must contain at least one heteroatom other than carbon atom. It is the heteroatom such as oxygen, nitrogen, sulfur, phosphorus, silicon sometimes. So these compounds they are the heterocyclic compounds. They contains the heteroatom. The furan it is a 5-membered cyclic compound which contains oxygen. Now for the application of the Huckels rule of aromaticity, you must know the presence of the lone pair of electrons on the various heteroatoms. For example, nitrogen contains the one lone pair of electron, oxygen contains the two lone pair of electrons. Determine the aromaticity of the following compounds. We'll take the examples here. Now first one is the pyrrole. So in the pyrrole, nitrogen has the lone pair of electrons which is parallel to the p orbitals of the carbon atom. This means that the pi electrons of the double bond, two double bonds and lone pair present on the nitrogen atom, these three pairs of electrons, they are involved in the delocalization of the electrons. So lone pair of electron is also involved along with the p orbital electrons of the carbon atoms. Now by applying the Huckels rule of aromaticity, 4n plus 2 pi is equal to 6 electrons. From where these 6 electrons came, the 1 pi bond is equal to 2 electrons. There are 2 pi bonds, therefore 4 electrons are there and one lone pair of electrons. So total 6 pi electrons are there. Therefore 4n plus 2 is equal to 6. This is the simple mathematical calculation. Therefore n is equal to 1. N is equal to a complete positive integer. Therefore the compound is aromatic. So pyrrole is a aromatic compound. Now consider the furan. Oxygen has the two lone pair of electrons. But both these two lone pair of electrons, they are not involved in the process of delocalization. One of the lone pair of electron, it is perpendicular to the p orbitals of the carbon atom. Therefore this perpendicular lone pair of electron, it will not be involved in delocalization of the electron. Another lone pair of electron will be parallel to the p orbitals of the carbon atom. Therefore this parallel lone pair of electron will be involved in delocalization of the pi electrons along with the p orbitals of the carbon atom. So only one lone pair of electron will be considered for the calculation. Therefore by applying the Huckels rule of aromaticity, that is 4n plus 2 pi, number of electrons is equal to 6. Therefore n is equal to 1. N is equal to a complete positive integer. Therefore the compound is aromatic. Thiophene. This is similar to the furan. The parallel lone pair is considered and the lone pair which is at a right angle is not considered because sulfur is also containing the two lone pair of electrons. By applying the Huckels rule of aromaticity, 4n plus 2 pi is equal to 6. Therefore n is equal to 1. N is the complete positive integer. Therefore the compound is aromatic. Determine the aromaticity of pyridine. Pyridine is a 6-membered heterocyclic compound. It is a cyclic and planar compound. It contains the total 6 pi electrons. As there are 3 double bonds, therefore the total 6 pi electrons. But here the lone pair of electron is present on the nitrogen atom. Now if you are looking over the molecular orbital structure of the pyridine, you will find there that the lone pair of electron on the nitrogen, that is represented in a blue dumbbell, the two electrons, they are perpendicular to the p orbitals of the carbon atom. Therefore this lone pair of electron is not involved in case of the pyridine for delocalization of the electrons. Therefore while calculating the total number of pi electrons, we will not take into consideration the lone pair of electrons. By applying the Huckels rule of aromaticity, 4n plus 2 pi is equal to 6 electrons. By simple calculation, n is equal to 1. As n is equal to the complete positive integer, therefore the pyridine is a aromatic molecule. Now determine the aromaticity of the following compounds. Benzene. It is a cyclic and planar compound. Secondly, it contains 6 pi electrons. 3 double bond means 6 pi electrons. Applying the Huckels rule of aromaticity, n is equal to 1, and as the n is the complete positive integer, the compound is aromatic. Now next compound is cyclooctatetraene. As this is the cyclic compound, therefore the word is cyclo-octa. As there are 8 carbon atoms, therefore it is the octa. Tetraene means what? The total 4 double bonds are there. Therefore the compound is cyclooctatetraene. Now what is the geometry of this cyclooctatetraene? It is a cyclic, but it is not a planar structure. It is a basket shape. It contains 6 pi electrons. Now by applying the Huckels rule of aromaticity, total 8 pi electrons are there, 4 double bonds and 8 pi electrons. So 4n plus 2 pi is equal to 8. Now n is equal to 6 by 4. This is not the complete integer. This is your half integer. Therefore, the structure does not obey Huckels rule of aromaticity. Therefore, compound is not aromatic. Now, why the cyclooctatetraene is not aromatic? Now, first thing is that the structure is not a planar structure. It is a basket-shaped structure. And second thing is that it does not obey the Huckels rule of aromaticity. This criteria 3, that is 4n plus 2 pi number of electrons, is the Huckels rule of aromaticity. But compound should obey all these 3 criteria, that it should be a cyclic and planar. Again, it contains the sp2 hybridized atoms. Then it should obey the Huckels rule of aromaticity. Now consider the naphthalene. It is cyclic and planar compound. It contains 5 double bonds. 5 double bonds, therefore it contains the 10 pi electrons. So 4n plus 2 is equal to 10. 4n is equal to 8. N is equal to 2. As the value of n is complete positive integer, therefore it obeys Huckels rule of aromaticity. Therefore the compound is aromatic. Now how to determine the aromaticity of the various ions? We will consider the first one, cyclopentadienyl anion. Cyclopentadienyl anion. This means that it is having the one more pair of electron. It is a nucleophilic one. It is a nucleophile. If we consider the total number of pi electrons, then 2 double bonds, that is the 4 electrons, and the one more pair of electron, that is total 6 electrons. So the compound is aromatic. Cyclopentadienyl cation. This is the electrophile. The electrons, they are lost by the carbon atom. Therefore carbon possesses the positive charge. So how many electrons are there? There are total only 4 pi electrons. So compound is, if we are applying the Huckels rule of aromaticity, then compound is not aromatic. Cyclopentadienyl radical. Now radical contains the odd number of electrons. So the carbon atom is containing only one electron and the remaining 4 pi electrons are there. So the compound is also not aromatic compound. Cycloheptatrienyl anion, it contains total 8 pi electrons, 3 double bonds equal to the 6 pi electrons and the 2 electrons of the anion. So total 8 pi electrons. Now calculate for cycloheptatrienyl anion. Pause the video for a while and calculate by applying Huckels rule of aromaticity. For cycloheptatrienyl cation, it contains the total 6 pi electrons, that is 3 double bonds and 3 double bonds corresponding to 6 pi electrons. Cycloheptatrienyl radical, it contains the total 7 pi electrons, therefore the compound is not aromatic. So among these three compounds, if you solve properly, cycloheptatrienyl anion and cycloheptatrienyl radical, they are not aromatic compounds. Only cycloheptatrienyl cation, it is the aromatic compound. It is also known as the tropylium ion.